Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The US East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the US East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100.
Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last ice age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually, it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures: mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real Ice Age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
The Arctic is disappearing. In just a few years, the North Pole could see its first ice-free summer in the last 125,000 years. But a bold new experiment might turn back the clock. Scientists are refreezing the Arctic. If they succeed, they could save the North Pole. But if they fail, they could trigger unforeseen disasters. So, which way would things go? Well, here's some backstory. Deep in the Arctic, temperatures drop so low that metal cracks and winds scream across the ice. In winter, it's minus 30 degrees Fahrenheit on average. But despite the seemingly extreme cold, it's actually melting, warming 2 to 3 times faster than the rest of the planet. Now, ice is like Earth's natural mirror. It reflects sunlight back into space, keeping the planet cool. When it melts, it exposes the dark ocean underneath. The ocean absorbs sunlight instead of reflecting it, and it spreads all across the planet. This warms the planet even faster, melting even more ice. It's a vicious cycle, and if it continues, will reach a point where the ice won't come back. That thick, ancient ice that has covered the North Pole for thousands of years is already 95% gone. It's been disappearing since the 1980s. The ice that remains there now is thin and fragile, and when it disappears, it will trigger a dangerous chain reaction. Meanwhile, a group of researchers from a UK startup called Real Ice is out there trying to slow down or even reverse the melting of the Arctic. The project takes place in a tiny frozen village in Canada called Cambridge Bay. Real Ice wants to break the vicious cycle, and here's their plan. First, they drill through the existing ice and place an underwater pump beneath it. Then they pump seawater onto the ice surface, where it quickly freezes into an extra thick layer. Finally, they remove snow from the ice, which usually acts like a blanket, preventing further freezing. After that, ice keeps growing, stronger, thicker, and harder to melt. It's a simple idea inspired by nature itself. Ice naturally forms this way in some Arctic regions, but now scientists want to do it on a massive scale. So far, it appears to be working. Between January and May 2024, they covered around 44,000 square feet of ice, and it became 20 inches thicker on average. And in November 2024, they started a new round of tests. In the first 10 days of the trial, the ice was already 4 inches thicker. Now they'll return in May 2025 to check out how things are going. They think it's going to get between around 16 to 31 inches of it during the Arctic winter. It's a small start, admittedly, but if they can prove it works, their plan is to expand across an area more than twice the size of California, about 386,000 square miles of ice. And they're not stopping there. The big idea is to send in 500,000 underwater drones, powered by clean energy, to automate the entire process. These drones would drill holes, pump water, and refreeze the ice without human intervention. But not everyone is convinced. Some scientists think this whole idea is a disaster waiting to happen. First, they point out that saltier ice, the one from seawater pumped onto it, melts faster in the summer. So if this new ice melts too quickly, we could end up making the situation worse. Some of them also think this is a dangerous distraction from the core problem, like treating the symptoms instead of the root causes. Besides, making a small patch of ice thicker is one thing, but doing this across the entire Arctic? That's another challenge entirely. Another thing they're worried about is the ecosystem. The Arctic is one of the most fragile ecosystems on Earth. Changing ice thickness could affect marine life, disrupt algae growth, and impact the food chain in ways we don't fully understand. There's also the question of money. Real Ice estimates that refreezing the entire Arctic will cost about $5 to $6 billion per year. Who's paying for this? Right now, they're self-funded with some investors backing them. But eventually, they hope that countries, global funds, and even corporations will finance the project. Real Ice argues that doing nothing could be far worse. If we don't act, we could lose the Arctic within our lifetime. That could at least help to buy more time to fix the planet. Desperate times call for desperate measures. Now, the idea of saving the Arctic ice isn't new. Over the years, scientists have suggested some pretty wild plans to stop the melting. In 2017, there was the initial wind-powered pump plan. Physicist Stephen Desch proposed installing about 10 million wind-powered pumps in the Arctic. These pumps would pull seawater up onto the ice, kind of like real ice. It would freeze in the cold winter months, creating a thicker ice layer. The biggest problem is that someone would have to run this entire show. And what happens if something goes wrong? In 2018, there was the Glass Beads Plan, which was supposed to start in 2020s. A team called the Arctic Ice Project suggested covering the Arctic with tiny reflective glass beads. Yep, glass balls. The idea was basically to replace the ice's mirror effect. The beads would bounce sunlight away, keeping the ice colder for longer. The plan is being tested by a group of scientists working with the Arctic Ice Project. They say the glass balls are made of a material that's safe for animals. They even claim birds use similar materials to help them digest food. The glass used in these microspheres is the same material used in lab equipment and light bulbs. Sounds safe, right? Well, not so fast. There's also the environmental risk. These glass balls are tiny, and they could easily get into the ocean, impacting everything from fish to plankton. We still need more research to understand how this material breaks down in the ocean and whether it could affect marine life. But where things get really crazy is when we start talking about scaling this up. To cover just a tiny fraction of the Arctic, they would need millions of tons of these tiny microspheres, and that's just for starters. And they'd have to be working 24/7 through freezing temperatures and snowstorms. The scientists believe this could help keep the ice thick enough to survive summer and even slow the melting. But can it really work? Then, there's also the Bright Ice Initiative, founded by the same folks behind the Arctic Ice Project. Instead of focusing on the Arctic Ocean, they want to use the same glass microspheres to restore glaciers. They've even tried this out on a glacier in Iceland, but experts are still skeptical. They say it could just speed up melting instead of reversing it. Now, another idea was cloud seeding with water particles. This would involve spraying ocean water into the sky itself. This would form clouds, and they'd reflect more sunlight. So, as you can see, some of these plans were too expensive, too complicated, or just straight up wild. The real ICES plan borrows ideas from earlier projects, but is much cheaper and more practical. Most importantly, it's working. But all this Arctic disaster is already affecting people. In the village of Newtok, Alaska, the land is disappearing. Each year, about 70 feet of the riverbank erodes, taking homes and history with it. That's all because of the erosion and the thawing permafrost. Now, these people had to move to a safer place called Murtevik, just 9 miles away. But it's a long and challenging journey. The relocation is taking years of planning, with Newtok residents already starting the shift in 2019. The new village offers better health and safety, but it's still a work in progress. Things like the school and grocery store remain in the old village, which makes things harder. Water and sewage systems are being set up, and for now, most residents are using a honey bucket system. But at least they have a chance to rebuild. It's still unclear whether these geoengineering ideas are a lifeline or a disaster. For now, we can just keep an eye on them.
On March 24th, European skies were dominated by a glowing, insane blue spiral. The eerie sight kept growing, expanding, almost like the whole Earth was about to get sucked into a vortex. And after a couple of minutes, poof, it suddenly disappeared. Even though it looked like some kind of extraterrestrial tech, there's actually a very human explanation behind it. Photos of this strange swirl started popping up all over Europe, with people sharing them from countries like the United Kingdom, France, Norway, and Germany. But if we really want to figure out what happened, we have to look all the way over to the United States. Turns out, on that same day, SpaceX's Falcon 9 rocket was launched from Florida at around 1:50 in the afternoon local time. So while most people in the US saw clear skies after the launch, it actually caused that strange anomaly in the European skies. And that happened because Falcon 9 is a reusable rocket. So, after launching into space, it releases what is called its payload. And by that, I mean whatever it is carrying, like a satellite. After completing its mission, the rocket itself turns back toward Earth. As it does, it ejects any leftover fuel, which instantly freezes due to the high altitude, forming a spiral pattern because of the rocket's movement. Light then reflects off the frozen fuel, making it visible from Earth. Basically, that's what the blue spiral was, leftover fuel released by the rocket in space. So, should we be worried down here on the ground? I mean, is it dangerous? Well, no. It's not like it was some kind of spacecraft accident, it's just leftovers and light. And this is totally normal for the Falcon 9 rocket. Even though it went viral this time, the same phenomenon was spotted about 4 years ago. Back then, people speculated all kinds of things, like a swirling galaxy moving across the sky, or even an unidentified, unexplained flying object. But nah, it was just one of Elon Musk's space toys. Speaking of which, his space agency is also behind another eerie sighting that's becoming more common. On clear nights, many people have reported seeing a strange string of lights moving quickly in a straight line, almost like a train of stars. Those aren't drones, and they're definitely not perfectly organized shooting stars. These strange lights are actually Starlink satellites from SpaceX. You know, that project that beams high-speed internet from space using thousands of tiny satellites, basically turning the entire planet into a giant Wi-Fi zone. But wait, satellites don't have lights on them. So how is it possible that they look so bright at night? Well, basically, what we're seeing is the sun reflecting off the satellites as they travel through their lowest orbit. And they're only visible if the sky isn't too bright. What's really impressive is that you can see this same event more than once on the same day. That's because Starlink satellites travel at a staggering speed of 300 miles per minute, and they complete one full orbit of Earth every 90 minutes. So, doing the math, that means you could spot those satellites within 2 hours of a previous sighting. Without a doubt, the beginning of the year was busy for skywatchers in the United States. In February, they got to see this stunning, cloudy jellyfish shape taking over the sky. What do you think it is? If you guessed another thing related to SpaceX, you're right. This is another art created by a Falcon 9 rocket. This time, it happened because the rocket was launched during the evening twilight. The light from the setting sun bounces off the rocket's smoke trail, creating this amazing effect. Now, let's move on to Italy, where another creepy event occurred. It was a stormy night, and suddenly, way up in the sky, a giant glowing red ring flashed for just a split second. Nope, it was not an extraterrestrial portal. This is something called an ELV. This happens when a powerful lightning strike sends out an electromagnetic pulse that hits the ionosphere, which is a super high up layer of our atmosphere. When this happens, nitrogen atoms up there get excited and glow red, creating a massive but super quick light show. Another red phenomenon happened in Scandinavia, but instead of a ring, it was more like a streak of light. This is known as a stable auroral red arc, or SAR. Despite the name, it's not an aurora. It's something much rarer. This phenomenon happens when the Earth's magnetic field, which acts like a big protective shield, gets disturbed. This disturbance causes some gas in the atmosphere to get super hot, thanks to a huge electrical current around the planet. What's weird is that only oxygen gets heated up during a SAR, which is why these light shows always glow that same red color. And fun fact, this event is more likely to happen after a big solar storm weakens Earth's magnetic field. It is impressive to see phenomena like this with the naked eye, but the view from outside Earth can be just as stunning. In 2022, an astronaut aboard the International Space Station spotted two bizarre blue blobs of light glimmering in our planet's atmosphere. They happened at the same time, but they weren't related at all. One of them was a massive lightning strike that hit right next to a large circular gap in the clouds. The lightning lit up the surrounding cloud walls, creating a glowing ring around the hole. Another one was caused by the moon. The way the moon was positioned made the sunlight it reflected pass through Earth's atmosphere, creating a bright blue blob with a fuzzy ring around it. And if you're wondering what that weird orange halo is, running parallel to the curvature of the Earth, I've got you. That's the edge of the atmosphere, also known as Earth's limb. And this is what it looks like when viewed from the International Space Station. In Canada, residents of central Alberta were looking up at the sky one night when they suddenly saw something strange. A bunch of vertical beams of light that seemed to be coming from the ground and reaching up into the blackness of space. It sure looked like something out of a science fiction movie, but this is actually just an optical illusion. Yep, it's a visual trick caused by some specific winter conditions. This phenomenon happens when light is refracted by ice crystals. Here's what's going on. When it's freezing outside, tiny ice crystals form in the air. These crystals are super thin and flat, so each one acts like a tiny mirror that reflects light sources positioned below it. Basically, the crystals reflect the light straight up, creating those glowing vertical beams. And it can be caused by any light source, like the sun or the moon. But in most cases, the sources of these light pillars is man-made, like car headlights or streetlights. Even though the phenomenon is completely natural, it rarely happens, and only in very specific situations. First, it has to be freezing cold. On that particular day in central Alberta, for example, the temperature was around minus 30 degrees Fahrenheit. Then, the weather has to be calm, with no wind at all. If a storm breaks out, forget it. You won't be able to see the light pillars. And don't mix them up with auroras, okay? Auroras are mostly seen in high-latitude regions, like around the Arctic and Antarctic. Since they happen way up in the atmosphere, they're visible over large areas. Light pillars, on the other hand, are more localized and concentrated in a much smaller area. But hey, no matter which one you spot, if you're lucky enough to see one of these amazing sights in the sky, you're in for a show you won't forget.
So the Sahara Desert is so big that it covers 8% of the world's territory. It's bigger than the USA or China. Surprisingly, the Sahara is not the largest desert in the world. It is the third largest, behind Antarctica and the Arctic. But it is definitely the hottest one. Temperatures there reach 136 degrees Fahrenheit. This place has some of the most incredible sand dunes you've ever seen, towering up to 1,476 feet. But here's the kicker. There's a real risk that these dunes might continue to spread until they cover the entire world. Surprisingly, the influence of the Sahara Desert extends far beyond its borders. Its dust, carried by powerful winds, makes its way to the UK and across the European continent, particularly in winter. This dust, settling on the ground where it rains, is a familiar sight to those in the UK, often leaving a red residue on cars. This connection between the Sahara, England, and Europe serves as a stark reminder of the global reach of environmental phenomena. You might think this is not a big deal, but it could turn Europe into a desert, leaving its soil infertile and Europeans with no food. Soil is a fundamental aspect of human existence, just as crucial as clean water and air. Without it, we're left with nothing but a bleak and barren landscape. The Sahara Desert has already made its jump across the Mediterranean Sea, which is concerning and could change the landscape forever. 1/5 of Spain has already turned into a desert. The next victim is Italy, which also faces the problem of desertification. In fact, almost all European countries have the same issue. According to an expert, the land that has not changed for nearly 2,000 years will become mostly rock, and people living on this land will be gone. 60% of the soil in Moldova is gone, and the problem has expanded beyond the Black Sea. It has reached China and Mongolia, thousands of miles away from the Sahara Desert. All of this causes losses of $4 billion a year. The threat is so significant that even the UN has gathered the necessary resources to solve the problem as soon as possible. Italy is sending help to Africa to stop the Sahara Desert from expanding. If this process does not stop in the next 10 years, millions will be forced to leave their homes. The Sahara Desert is growing for approximately 30 miles per decade. You do the math and see how long it will take to cover Europe. Since 1920, the Sahara has expanded by around 10%. But not all hope is lost because more than 172 countries have joined to put a stop to the desertification of the world. The World Food Program is a project that aims to help bring back green land that was once present in the Sahara. When they told people who called the Sahara home what they were about to do, the latter basically laughed in their faces and said it was impossible. But when you have a specific goal in mind, the impossible becomes possible. If we traveled back around 5,000 years into the past, we would see a beautiful forest with lush green trees and grass. Africa's climate has been changing for 21,000 years, from fantastic greenery to uninhabitable deserts. This has to do with Earth's rotation and the monsoons that bring water to this dry continent. But with the help of scientists and some clever tricks, we can bring the greenery back and stop the Sahara in its tracks. The Senegal River serves as a border between the Sahara Desert, Senegal City, and Mauritania. When you look at this area from space, you'll see how the desert is expanding to Senegal because the vegetation along the riverbank is almost non-existent. Forests can serve as a barrier, stopping the sand from getting blown away and the desert from expanding. An effort to create a great green wall is being made, and how they do it is actually quite impressive. Nothing has been growing in the currently restored area for more than 40 years, making locals find other places to call home. People were thrilled when they saw that the land could be restored. They're very committed and learn to work with the soil and grow food. At the same moment, more than 30,000 hectares have been restored and transformed into lush greenery. The Sahel region is the starting point of desertification, and it is crucial to establish a green wall in that area first. To make this wall is not rocket science, since it only takes a few simple steps. The ground there is baked by the sun and is hard as a block of concrete. If you've ever poured water on concrete, you know that it just flows away. It doesn't stay in one place. So they had to create water-retaining half-moons that would hold the water and make it available to plants. When you learn about how these half-moons work, you might say, how did they not think of that sooner? Actually, this technique is ancient, and it was once implemented in Sahel, but it was lost over time. When the rain falls, the water is collected into the half-moons that are positioned a bit lower than the ground below contour lines. There is also a kind of bank at the end of the shape that prevents water from overflowing, and in the middle, there are plants that are happy because they have plenty of water to thrive. Also, it's essential to grow native plants that are kind of used to harsh conditions, like sorghum and millet. These plants have been surviving there for thousands of years and produce a good amount of biomass, which means the land can be rehabilitated faster and people will have food sooner. The water that will enter the half-moons won't be lost. It will penetrate the ground and top off underground waters. This will ensure the ground that H2O will never run out and that future generations will have usable aqua. This brilliant planting technique is not limited to half-moons. People also create lines and plant various vegetables, such as tomatoes. Next, there are places only for trees, like lemons or oranges. After a long hot day, nothing is better than a freshly made cold lemonade. The trees will also protect the soil, and with some luck, there will be a new forest in the Sahara Desert. The goal is to copy the forest dynamic. Start with small plants and gradually expand to bigger plants that are more useful than the tiny ones. They are aiming to plant more than 10,000 trees. Right now, many people are leaving the Sahara after the rainy season, going to cities or leaving Africa altogether. At this time of year, villages are like ghost towns. Only animals can be found there. Most people are gone. I mean, who would blame them? Nobody wants to live in the sand where nothing grows. Luckily, with all this new, old technology being developed, many people are slowly but surely returning to their land and starting to work in agriculture. The best thing is that there are no brutal winters, so plants grow 12 months a year, and people can always have food. People are becoming more social because now everybody stays in their villages and doesn't travel much. If this project works out, Africa will be saved, and the world won't turn into a giant desert.
Divers have found something incredible in a Florida sinkhole, and it was... Stop, we need to leave a warning here. You're about to hear some pretty unusual scientific information. This knowledge will make you the smarty pants in your friend group. But there's also a risk that they'll look at you as a nerd. So perhaps it would be better for you to keep this knowledge a secret. In any case, it won't be superfluous. So, you know that scientists divide the history of our planet not only by time periods, but also by which animals lived at a certain time. For example, 2,000 years ago, Earth was inhabited by the blobfish, and scientists call this time the blobfish period. It's a joke, there's never been such a period, but you get the gist. The period between about 419.2 million and 358.9 million years ago is called the Devonian period, or the Age of Fish. Do you know why? Because the first fish began to appear on the planet. The Paleogene is the period of large mammals. The famous Jurassic period marks the appearance of giant dinosaurs, which we often see in the movies. Even now, we live in a certain period called the Quaternary period. It began about 2.6 million years ago and continues to this day. This is the time of humans and modern animals. So the next time somebody asks you what time it is, you can just answer, it's the Quaternary period. In short, the names of these periods depend more on what creatures inhabit the planet. The longest period is the Precambrian period, or Age of Early Life, the time when life on the planet started to form. Soft-bodied worms and jellyfish swam in the ocean, while microorganisms lived on land. This period occupies almost 90% of the Earth's total geological time. It started about 4.5 billion years ago and ended 540 million years ago. Oh, it's still a video about divers, don't forget. We'll get back to them soon. Considering all these periods, do you know which one is of the most poorly studied? A period about which scientists know almost nothing, especially about the animals that lived at that time. This is the Irvingtonian North American land mammal age. It lasted from about 1.6 million to 250,000 years ago. Scientists have very few fossils that belong to this time, but recently, everything has changed. In the USA, there's the Steinhatchee River, which stretches for several tens of miles in the area of Big Bend, Florida. And just 500,000 years ago, there was a sinkhole instead of the river. This is a hole in the ground that forms when water dissolves the upper rock. This rock is often limestone. Sinkholes appear in places with a lot of precipitation. Sometimes these pits can be invisible. They look like ordinary ground, but the soil in them is loose and can easily collapse. If you accidentally get into a sinkhole, people will hear your screams and help you. But in the distant past, about 500,000 years ago, when animals got there, they couldn't get out of the pit, so it became their grave. After many, many years, a river appeared here, and then several fossil collectors decided to check out this place and discovered a real paleontological treasure in it. They plunged into the river and reached the bottom. There, in the murky water, they saw horse teeth sticking out of the sediment. It'd be pretty scary to find for many of us, but for these guys, it was the jackpot. After the teeth, they found a hoof shaft and the skull of an unusual animal. At that moment, the collectors realized they had made a major discovery. Over the years, the sinkhole at this place had been filled with sedimentary rocks. Then, the river compacted all this mass, which made it possible to keep everything inside the sinkhole in good condition. Many animals got trapped in this pit 500,000 years ago, and only now have people managed to get them out. More precisely, what's left of them. Divers have found more than 500 fossils belonging to ancient animals, including unknown species. They got well-preserved bones of ancient horses, giant armadillos, sloths, and a new species of tapir. The Florida Museum examined the remains and determined that they belonged to the poorly studied Irvingtonian North American land mammal age. Most of all, scientists were struck by two finds in this collection. The first was the remains of a giant armadillo-like creature, and the second was the skull of an ancient tapir. In case you didn't know, this is a very cute pig-like mammal that has a short trunk like an elephant. Divers in Florida found the remains of a distant ancestor of this animal, which may be a new unknown species. Most of the fossils in the sinkhole belong to early Cabalene horses, a subgroup that includes modern domestic horses. The remains of horses are so well preserved that scientists have seen signs of wear on their teeth. This will allow experts to understand the diet of these ancient creatures. We often hear news about people finding the remains of ancient animals or dinosaurs in caves, ravines, or at the bottom of lakes. But imagine if they found such remains in a museum. It all started in the early 2000s, north of the Florida border in southwest Georgia. There was a mine where workers mined clay. One day, they found the remains of some ancient animals and gave them to the Florida Museum of Natural History. There, these remains lay in storage, waiting in the wings. And then one day, some guy started sorting them out and noticed a mysterious vertebra of an unknown animal. This little grab caught the guy's attention, so he returned to it over and over again. He studied it, trying to figure out what species the bone belonged to. One day, he realized the bone belonged to an unknown extinct lizard species that looked like a tegu. You've probably seen these predatory creatures that look like monitor lizards. So, the age of the bone was about 15 to 17 million years old. Let's wrap up our video with something weird. You see this piece of amber-colored stone with stripes? Or is it not the stone? It looks like an ancient seashell. So right now, you're looking at the oldest fossil in history. It's a stromatolite, and its age is, you won't believe it. Make a guess. 100 million years? 500 million years? 1 billion? No. This fossil is about 3.4 billion years old. It represents one of the earliest forms of life on Earth. No, not the stone itself. Stromatolite is just a playground. The early form of life here is these thin strips. They're called cyanobacteria, tiny single-celled creatures. Okay, what about the remains of something bigger? Some ancient animals, for example? Meet the trilobites. They lived here during the Cambrian period, which began about 500 million years ago. This is the time when many invertebrates and fish began to appear. Their exoskeletons helped the trilobites stay remarkably well preserved, considering their age. They were arthropods that looked like something between a spider, a scorpion, and a mutant from another galaxy. These animals lived for a very long time, and people find their remains almost all over the world. They appeared at the very beginning of the Cambrian period, survived it, and became extinct at the end of the Permian period. During the Permian mass extinction, when about 90% of all living beings were wiped off the face of the Earth. These creatures swam in open water, burrowed into the seafloor, or crawled along it. They lived like predators and scavengers. The front of the animal was protected by a strong head shield. It had crescent-shaped eyes and a calcified plate on its lower body. This plate covered its esophagus and mouth. It had several pairs of legs growing from its body. The trilobite could also curl up into a ball, like a woodlouse.
Oh boy, scientists predict a volcanic eruption that is likely to be one of the most destructive in the history of our species. There's a 1 in 6 chance of it happening in this century, and it could seriously change the climate even more and put millions of lives in danger. Back in January 2022, the Tonga Ha'apai volcano erupted in the South Pacific Ocean, creating a huge explosion. It sent tsunamis all the way to Japan, North America, and South America. Tonga itself was hit hard, with damage costing nearly 20% of the country's entire economy. Now, researchers at the Niels Bohr Institute in Copenhagen have studied ice samples from Greenland and Antarctica, and their findings are worrying, predicting potential global volcanic disaster. They say there's a real chance of a much bigger eruption, a whopping 10 to 100 times larger than Tonga's. In the past, eruptions this size used to change the climate and even cause civilizations to collapse. Despite future volcanic eruption risks, experts say the world isn't prepared at all. Michael Cassidy, a volcanologist from the University of Birmingham, warns that no sufficient effort is made to handle a disaster like this. He says that NASA and other space agencies spend billions on asteroid defense, At the same time, a volcanic supereruption is way more likely than an asteroid impact, and right now, there's no global plan for dealing with a massive eruption, even though it's likely to be far more destructive. The last magnitude 7 eruption happened in 1815 at Mount Tambora in Indonesia. Then, thousands of people lost their lives in just a few days. The disaster also disrupted weather and caused food shortages worldwide, affecting millions. That eruption was the biggest in recorded history. It blasted a massive cloud of particles into the sky. Those particles blocked sunlight, cooled the planet, and caused worldwide chaos. The year after the eruption became known as the Year Without a Summer. Temperatures plummeted, crops failed, famine spread, and a cholera pandemic broke out, leading to tens of thousands of lost lives. A shocking fact, the eruption may have even inspired Mary Shelley to write Frankenstein while stuck indoors during the unusually cold summer of 1816 in Switzerland. Now since then, many volcanoes have erupted, but none have matched Tambora's scale. Now, over 200 years later, scientists warn that there's a new supervolcano threat. Another massive eruption could be on the way, and the world might not be ready for it. So, while scientists seriously discuss the likelihood of the next volcanic eruption, experts are calling for urgent action to prepare before it's too late. So the thing is, a massive volcanic eruption today could be even more devastating than the Year Without a Summer. Unlike back then, we're already dealing with all kinds of weather changes and a more fragile global system, which could make the effects even worse. Dr. Michael Rampino, a geological scientist, warns that the world is more unstable now, and it means that a modern-day mega-eruption could have even more severe consequences. But this time, greenhouse gases from fossil fuels may make the aftermath of such an eruption even colder instead of warmer. So we're talking about volcanic activity endangering humanity. Dr. Thomas Aubrey, a volcanologist, found that in a hotter, more turbulent atmosphere, the sulfur dioxide gas released by a volcanic eruption would spread faster and farther than in the past. This gas forms sulfate aerosols, which reflect sunlight and cause global cooling. Because these tiny particles would be more evenly distributed, they'd have a stronger cooling effect than in 1815. Another atmospheric scientist at Cambridge explains that the size of these airborne particles matters. It affects how they absorb sunlight, and in a future warmer climate, an eruption could make the surface cooling stronger by 15%. At the same time, there are still many unknowns. Scientists from the University of Geneva say that we're only beginning to understand the full impacts of such an event. It's also difficult to precisely estimate future volcanic eruption risks, since we have very little data on older eruptions. So, to understand past volcanic activity, researchers analyze ice cores from Greenland and Antarctica, as well as ancient tree rings. Those act as historical records of weather changes. These measurements suggest that several eruptions in the past few thousand years temporarily cooled the planet by about 2 to 2.5 degrees Fahrenheit. One of the most catastrophic examples is the 1257 Somalus eruption in Indonesia, which was so powerful that it likely triggered the Little Ice Age. It was a period of global cooling that lasted for hundreds of years. More recently, the 1991 Mount Pinatubo eruption in the Philippines slightly cooled Earth for a few years. Because this eruption happened in the satellite era, scientists were able to measure exactly how much sulfur dioxide was released and how it affected the atmosphere. But even with modern tools like satellites and seismic instruments, scientists still have difficult times forecasting the next big volcanic eruption. Luckily, even though we can't predict the exact timing, we can study worst-case scenarios to help authorities prepare. This includes creating evacuation plans and stockpiling food in case of global crop failures caused by volcanic cooling. The changes in weather patterns might make volcanoes more active. Melting glaciers can reduce pressure on underground magma, which will increase the chances of an eruption. Plus, more extreme rainfall, which is becoming more and more common, can seep into volcanic cracks and cause powerful steam-driven explosions. It can affect both active and dormant volcanoes. Because of these risks, researchers are now mapping volcanoes that are the most vulnerable to climate change. Their studies show that the highest supervolcano threat comes from such areas as Iceland, Chile, and Indonesia. Those are places where glaciers are melting quickly or rainfall is increasing dramatically. A 2022 study found that 716 volcanoes worldwide, that's about 58% of all known active above-ground volcanoes, could be triggered by extreme rainfall, increasing the likelihood of another mini ice age. Now let's get back to that Hunga Tonga Hunga Ha'apai eruption that occurred on January 15, 2022. Scientists have confirmed that it created the highest plume ever recorded. The volcano, located underwater in the South Pacific, sent an ash cloud 187,000 feet high. That's higher than any previously recorded eruption. What makes this eruption even more remarkable is that it was the first to ever reach the mesosphere. It's the third layer of Earth's atmosphere. The mesosphere begins at about 160,000 feet above Earth, where meteors start burning up and creating shooting stars. To measure the plume's height, researchers from the University of Oxford and RAL Space used data from 3 geostationary weather satellites. Before this, the record for the highest volcanic plume was held by Mount Pinatubo's 1991 eruption in the Philippines, which reached 131,000 feet high. Interestingly, this kind of measurement was only possible thanks to modern satellite technology, and a decade ago, no one would have been able to do this. Another volcano we should mention in relation to a potential global volcanic disaster is located on Iceland's Reykjanes Peninsula. Its latest eruption happened in November of 2024, leading to evacuations in nearby areas. The eruption began just after 11 p.m. with little warning. The volcano released orange lava from a nearly 2-mile-long fissure. Authorities ordered evacuations for about 50 homes and guests staying at the Blue Lagoon Spa Resort, a popular tourist destination southwest of Reykjavik. While air travel was not affected, officials still warned of potentially dangerous gas emissions spreading across parts of the peninsula, including the nearby town of Grindavik. Grindavik, home to 3,800 residents, has repeatedly witnessed volcanic activity, and past eruptions even damaged its infrastructure and forced evacuations. For example, in August 2024, a 2.5-mile-long crack opened at the Sunthunkangigar crater near Grindavik. It led authorities declaring a state of emergency as lava flowed in multiple directions. Fortunately, Iceland's meteorological office reported that the latest eruption was significantly smaller than the one in August. Geophysics experts conducted aerial surveys and figured out that the situation appeared less intense than the previous eruptions. These days, Grindavik is not at risk, but the possibility of further developments cannot be ruled out. Scientists predict more volcanic eruptions. So this huge volcano, everyone thought to be extinct, woke up and spat out a black ash cloud 50 miles high. That's about 9 times as tall as Mount Everest. Located in what is now Indonesia, the powerful Krakatoa had caused huge tsunamis that rocked over ships as far away as South Africa. It also changed the temperatures around the world for several years. The volcanic island of Krakatoa in the Sunda Strait was likely born thanks to another major eruption several centuries ago. It hadn't erupted for at least 200 years before 1883. So the first tremors and blasts in May of that year came as a total shock to people living nearby. Then ships sailing through the busy water passage started reporting clouds of ash above the volcano. It went quiet again for a while, but they could still see ash above it. The eruption culminated at the end of August. It was so powerful that it shattered the island into fragments. Witnesses heard the sound produced by it in Australia, around 3,000 miles away. They described the noise as the roar of heavy cannons. Some say it was the loudest sound ever heard. During the next 5 days, the pressure wave from the eruption traveled around the globe 3.5 times and was seen on barographs on different continents. Hot avalanches of ash spread down the volcano as far as 25 miles away at crazy speeds. They ruined the surrounding islands and took 36,000 lives. Tens of thousands more drowned in tsunamis that happened after the volcano had collapsed into the caldera. Over 100 coastal villages on Java and Sumatra were completely wiped out. All this made the waking up of Krakatoa one of the most devastating in the entire recorded history. The Earth's crust is like a giant puzzle, made up of massive pieces known as tectonic plates. These plates are constantly sliding against each other over the mantle, which is the molten layer beneath. Indonesia is right in the middle of the so-called subduction zone. Here, the Indo-Australian plate collides with part of the Asian plate as it moves northward. As the oceanic plate dives down, it gets heated up, and you've got the perfect recipe for a volcanic hotspot. Krakatoa had 3 peaks, each serving as an exit door for a massive magma chamber beneath it. During a previous eruption, debris blocked one of these exits, and the pressure built up beneath. When Krakatoa finally blew its top, the blast split the magma chamber wide open. The eruption led to a so-called volcanic winter. Krakatoa had sent 6 cubic miles of rock, ash, and debris into the atmosphere. They created a thick veil that surrounded the Earth. The particles scattered sunlight, and the troposphere below cooled down. The effect stayed strong for several years. The northern hemisphere experienced colder than average temperatures, and in some regions, summer temperatures didn't rise to typical levels. Southern California received a record amount of rainfall in the months following the eruption. The sky became darker in different parts of the world for years afterwards. The sunsets, for many months, turned into a spectacular show of red and orange. One astronomer supposed it was the source of the inspiration for The Scream by Edvard Munch. The painting shows exactly what the sky over Norway looked like after the eruption. It also produced a rare type of halo called Bishop's Ring and a volcanic purple light at night. For several years after Krakatoa had blown up, the moon looked blue and sometimes green. That's because some ash clouds were full of particles large enough to scatter red light, only letting other colors pass. Someone even witnessed lavender sun and night-shining clouds. Krakatoa became the first scientifically well-recorded and studied eruption of a volcano. Between the moments the first clouds of ash were seen by a ship passing by and the disastrous eruption, scientists managed to organize geological expeditions. They studied the volcano and gathered samples of volcanic rocks. It became useful for understanding volcanic activity. Krakatoa was sleeping tight until the 1920s, when some locals noticed a column of steam and debris spewing from the collapsed caldera. Within weeks, the rim of a new cone sprang up above sea level. After a year, it was a small island named Child of Krakatoa. It continues to erupt, but fortunately without serious consequences so far. In April of 1815, Mount Tambora unleashed a massive eruption, wreaking havoc on the Indonesian island of Sumbawa. It destroyed homes and claimed 10,000 lives. Another 80,000 perished because of diseases that spread in the aftermath. The following went in history as the year without a summer. Cold, wet conditions wrapped Europe and North America in an unexpected chill. It became the coldest in at least 250 years. In the summer of that year, the temperatures dropped the most. Crops didn't grow, livestock didn't survive, and famine took over Western Europe and North America. New England had snow and terrible frost in the summer months. Food prices went up. Oats for horses became a luxury. Some people say it even inspired the invention of the bicycle in 1817. Scientists used early data and climate models to see if it was all because of the Tambora eruption. They compared the data to similar years. They showed that precipitation was around the same, but the temperatures were much warmer. When they introduced the volcano into the scenario, they got the exact data for the year without summer. They say that a powerful volcanic eruption like that one increases the likelihood of extreme cold by up to 100 times. The explosion of the Toba supervolcano on the island of Sumatra around 74,000 years ago became the Earth's largest volcanic eruption in 28 million years. Parts of Indonesia, India, and a slice of the Indian Ocean got a cozy blanket made up of 6 inches of volcanic debris. It spat out a volume of rock comparable to almost 3 million Empire State Buildings. The crater it had left behind is still seen from space. All the ash and volcanic gases that sprang into the atmosphere because of the eruption partially blocked the sunlight. A severe volcanic winter began and lasted for 6 to 10 years. Some anthropologists see a connection between the Toba eruption and how limited modern humans are when it comes to genetic variety. Around 74,000 years ago, exactly when the Toba erupted, there was a population nosedive. That's why all modern humans trace their roots back to a tiny group of survivors. The Toba catastrophe theory proposes that most early humans in Europe and Asia didn't make it through the post-eruption climate chaos. Instead, a lucky, genetically limited bunch found their safe haven in Africa. But archaeological and paleoclimate records disagree with this theory. Benjamin Black from Rutgers University and his team set out to crack the code and discovered a hidden paradox. Maybe we were peering through the wrong climate lens. They ran 42 different climate model simulations, varying the magnitude of volcanic emissions, time of year of the eruption, background climate state, and eruption column height to see what climate disruptions the Toba eruption might have caused. There was a significant drop in temperatures in the northern hemisphere in the first year after the event, up to 18 degrees Fahrenheit. The southern hemisphere, where the early humans were settling, didn't go through a rough cooling that could have affected them all. The most significant eruptions that can seriously change the world's climatic patterns come from supervolcanoes like Yellowstone or Mount Toba. Luckily, these erupt very rarely, about every 100,000 years or more. Still, climate scientists study volcanic eruptions to understand and explain short periods of cooling in the history of our planet. Every few decades or so, a volcanic eruption lets out a substantial number of particles and gases. Some of them will block enough sunlight to start a brief global cooling period. Nothing like the real volcanic winter, but still felt across the globe.
The last time this volcano erupted was about 500 years ago, but recently, small tremors have grown really frequent, to such an extent that scientists have been recording more than 1,000 a month. I'm talking about the Campi Flegrei supervolcano in Italy. At one point, just a few weeks ago, the area was rattled by a 4.4 magnitude earthquake with 150 tremors in just one night. It was the strongest earthquake in over 40 years. A lot of locals spent the night in their cars, but in the morning, the shakes were followed by another earthquake, a bit weaker with a magnitude of 3.6. So, is Italy in danger? Well, the quake itself wasn't big enough to cause serious damage, but it evoked a lot of panic. At the moment, local authorities are working on grandiose emergency plans. If worse comes to worse, they'll have to evacuate hundreds of thousands of people. One of the reasons is the proximity of this area to Naples with more than 3 million inhabitants. At the moment, they're even considering an option of paying people to leave their homes. Right now, schools remain closed in the Campi Flegrei area. The authorities are allocating more than 500 million euros to ensure the safety of buildings and constructions in the area. A yellow alert is still in place in the region, where 80,000 people live. There's the so-called red zone, which is the most dangerous area. There are 1,250 houses in this red zone, and all of them will be at high seismic risk if an eruption begins. Plus, more than twice as many will be at medium risk. Italy is a country prone to seismic activity, and Pozzuoli is a densely populated area that is located on one of the most dangerous supervolcanoes in Europe. Campi Flegrei has 24 hidden underground craters and dwarfs the better-known Vesuvius. Yes, the very volcano that wiped the ancient Roman city of Pompeii off the face of the earth in 79 CE. This city thrived near the base of Mount Vesuvius at the Bay of Naples. In the time of the early Roman Empire, 20,000 people lived in Pompeii. They were merchants, manufacturers, farmers, and others. The soil in the region was rich and fertile, so there were lots of orchards and vineyards. Strangely, no one knew that this black earth was the legacy of an earlier eruption of Mount Vesuvius. The area was a favorite summer destination for rich Romans. Sadly, at noon on August 24, 79 CE, all this prosperity came to an end. The peak of Mount Vesuvius exploded, sending a 10-mile-high mushroom cloud of ash and pumice into the stratosphere. For the next 12 hours, the eruption was wreaking havoc on the city. Volcanic ash and a hail of pumice stones, some of which were 3 inches in diameter, showered Pompeii. It forced the city's occupants to flee in terror. Around 2,000 people holed up in stone structures and cellars, paralyzed by fear. They hoped to wait out the eruption. Who knows? Maybe if they had decided to leave the city immediately after the beginning of the eruption, they would have had some chances to survive. A westerly wind protected the city from the first stages of the eruption. But soon, a giant cloud of hot ash and gas rushed down the western slope of Vesuvius. It engulfed the city, burning everything in its way. This disastrous cloud was followed by a flood of volcanic mud and rock, which completely buried the city. As if the volcano was making sure no one would survive, a cloud of toxic gas poured onto the city, finishing the lives of a few survivors on August 25th. A flow of rock and ash followed. It collapsed roofs and walls and turned the city into a giant cemetery. When a supervolcano erupts, the consequences are usually catastrophic. Supervolcanoes have at least once had an eruption with a volcanic explosivity index of 8, which is the largest recorded number on the index. Supervolcanoes are often extremely large, with no cone at all. That's because they're typically the remains of gigantic magma chambers that once flared up, leaving behind a caldera. They're usually located over hotspots and appear when huge volumes of magma are trying to escape from deep underground. Eventually, they burst through Earth's surface. Sometimes, all this magma gets stuck, unable to break through the planet's crust. And then, massive pools of pressurized magma gather at a depth of several miles. The pressure keeps growing because more and more magma is trying to get to the surface. At one point, a super eruption goes off. The most recent super eruption happened in New Zealand. Well, when I say recent, I meant around 26,500 years ago. That's when a supervolcano beneath the surface of Lake Taupo spewed into the air more than 300 cubic miles of ash and pumice. Imagine 500,000 Great Pyramids of Giza flying up into the air at the same time. That's how incredibly powerful that eruption was. But the most exciting and confusing thing about the eruption was that the Taupo volcano didn't simply go off like many others. At first, everything was going as usual. Tons and tons of pressurized magma had built up under the surface, and the pressure was getting higher and higher. But after the rock cracked and the first portion of lava rushed out of the crater, something went wrong, and the supervolcano took a break. Only several months later, the disastrous eruption shook the ground. Thousands of tons of lava, rocks, and ash flew high into the atmosphere. The unusual pattern of Taupo still confuses scientists. The Indonesian eruption at Toba caldera 75,000 years ago was the largest eruption in the last 2 million years. Experts estimate that the eruption could have released hundreds of thousands of tons of sulfuric acid, which might have even caused a several-degree cooling of the planet's surface. But nowadays, the impact is hard to detect because of glaciers that covered the ground afterward. There are also several so-called supervolcanoes that haven't lived up to this name yet because they've never produced any super eruptions. For example, in 1883, Indonesian volcano Krakatoa went off. The power of the eruption tore the volcano's walls open, and cold seawater rushed into its molten insides. The difference in temperatures made the volcano blow up with a deafening boom. It was clearly heard 3,000 miles away in Australia. It earned the blast the title of the loudest sound in history. But even though the consequences of this event were truly catastrophic, it still turned out not powerful enough to be called a super eruption. It only had a volcanic explosivity index of 6. Then, there's also Mauna Loa. It's a shield volcano, which means it won't produce explosive eruptions, but its sheer size makes this monster of a volcano extremely dangerous. At the moment, the volcano seems to be at peace with its surroundings. Research equipment doesn't show any signs of activity on Mauna Loa, but if Mauna Loa did suddenly erupt, lava flows could reach the ocean and the most populated and touristy places like Captain Cook very fast, in a matter of hours. The last time the volcano erupted, lava got as far as the outskirts of Hilo on the other side of the island. That's where the University of Hawaii is located. Luckily, people had a few weeks' warning to get ready for the disaster. Over its recorded history, Mauna Loa has been erupting pretty regularly, almost every 6 years. On the bright side, big island volcanoes including Mauna Loa aren't really very volatile. That's because they're shield volcanoes. These volcanoes got such a name because they aren't really very high and resemble a warrior's shield placed flat on the ground. Shield volcanoes are formed by very fluid lava. It travels way farther and forms much thinner flows than the lava erupted from a stratovolcano, which is conically shaped and tall, like the infamous Krakatoa in Indonesia. So, if Mauna Loa erupts, there probably won't be ash clouds or tons of debris. The most dangerous thing will be lava. Since Mauna Loa is a shield volcano, its lava is extremely fluid and voluminous, which allows it to flow far and fast.